welcome.
Okay, cool. Cool. All right, we got him. Sweet. Yeah. Hey, everybody. Let's dive in. So we're going to talk about the future is distributed. A little play on words here. We're talking about on-chain data specifically. So I'm Brock, founder and CEO here at the indexing company. I have a weird passion for data. I don't know why. Specifically data infrastructure. Been in crypto since 2017. So seen all the cycles, worked at Coinbase, been through it. So today, we're going to start a company. So let's do a DeFi protocol. It's going to be ZK-powered, AI-powered, all for the investors, of course. And privacy-preserving trading algorithms. So let's say that we are trying to transact on-chain. We're leveraging ZK and AI to make a profit and keep it secure and private. All right, my images might not show up. That's okay. So steps here, we're going to incorporate first. We're going to fundraise, usually in that order. Somewhere along the way, we get to building. Most of us are builders here, so we'll focus on that step. Yeah. All right, so the MVP. Usually by this point, you have something shiny UI. Maybe you've vibe coded something. It works if you say the right prayers. And usually it's powered by third parties. That's the big call out here. You're using other APIs. You are building exactly enough to get it to work and nothing more. And that's the point. I don't know. All right. None of my images are showing up, so we'll skip that. That's okay. Anyways, if this was here, you could imagine in your MVP, you have some architecture. You've got users over here on the right. You've got your own database internally. You've got some servers connecting those. And the call out would be that there is a third-party provider giving API access to all of this. So accessing on-chain data, accessing APIs. Maybe you want to call RPC methods. Maybe you want to get token balances, whatever it might be. You're likely using someone like a ThirdWeb, a Covalent, an Alchemy, maybe even the Graph. Those are going to be plugged into your databases directly, as well as your front ends. And then along the way, you get feature requests. So customers start asking for new chains. There's a lot of Avalanche L1s. You might need more insights. Maybe you need faster agents. You start getting requests that your existing data providers can't handle. And so as you start to get here, you're now then either one, looking for more providers, or two, looking to start building in-house. So imagine that same scenario. You've got users on the right. You've got third-party APIs, except a lot more of them now. You've got your own database. You've got connective tissue in between. But now you've also started building up your own in-house infrastructure, doing a ton of work on top of all of this. You're doing processing. You're doing more normalizations, connecting maybe to different RPCs directly. It starts to become a mess. So why do we keep reinventing the wheel? What I described is a fairly universal architecture. For any of us that have built programs in Web3, you've probably done something very similar. So what happens? 50% of raised funds are spent on data infra. Teams are hired despite a lack of domain expertise. On-chain data is different, but nobody starts from that first principles. They're focused on building the product, building the user experience, which is great, but they're not focused on the in-between, how to go from A to B. And so all of this leads to resources are used on things that don't actually support the business, right? The infra is not what makes you unique. So that's what this says. Data infra does not make your business unique. It's worth saying twice. So specifically in the Web3 world, the way I like to view it, open data is supposed to mean data sovereignty. You're supposed to be able to control your own data. We have that ability to an extent as we're pushing data on chain, we're writing transactions, we're signing on behalf of ourselves. We don't necessarily get that same control on the reverse. When we're building products, we're usually reliant on other providers. Think we can do better. So switching gears slightly, talk about data indexing for a minute. If we think of data as bits of information, Indexing is then the process of making those bits usable. And I'll get into a couple examples, but this is sort of the universal definition, if you will. So again, no image, that's okay. But some examples of indexers. Librarians, one of the first ones. If any of you have actually gone to a library and used the catalog cards, that's a form of indexing. They take all the books, they say, hey, these books are in these sections, and they create cards to help you find those. Databases do this as well. You have a table of data, maybe you have millions of rows. You can create an index in that database to more quickly look up the rows you need. This is where you get into partitioning, clustering, there's all sorts of advanced ways to do that. And then you also have more abstracted concepts of indexing, specifically in the Web3 world, like the graph, where they connect to multiple different chains. They're taking that data off this global shared data lake and putting it into another database that makes it slightly more usable. This is how they can power APIs. This is how they can make that work. So again, it's, if I go back, bits of information, whatever that is, books, on-chain data, records in a database, and then indexing is the process of making those bits usable. So the way I see it, much of what needs to happen is we need to shift to treating data as a product itself. We need to be focused on users, not the sources of data. So understand where the business needs to go, the products we need to build, and then back into how to source that data. We're often stuck doing the reverse in Web3. Build pipelines to rapidly iterate. So instead of just plugging into APIs and trusting that the APIs are there, if we're focused on users, we have the opportunity then to build a data pipeline that you can iterate on. Something that lets you transform that data on the fly, iterate on it, test it, and then when your needs change, your pipeline can adapt as well. And all of this ideally is embedded then in the engineering culture, where data is not just a commodity that you buy, but it's really something that's used throughout the engineering organization and to power all the products as well. Getting a little more specific here, I think one of the ways that we can work towards this is we can produce with intent. So less so these days, but earlier in the EVM world, there was a lot of debate about whether or not we should do on-chain logging. I say at this point we should lean into it. Gas is cheap. If you need data accessible, log it on-chain. Treat contracts as software. There should be proper DevOps lifecycles for contracts, and the on-chain logging is quite literally logs from those bits of software. And then ultimately, don't get cute with it. Don't try to reinvent the wheel. Don't try to do anything crazy. If there's a standard out there, leverage it. It'll help you later. All of this, the idea being if you take a step and think about the data you're producing on chain, it'll make it much easier to use later. Yeah, you're not going to see it here again, but imagine with me one more time. Users over here on the right, your servers and databases in the middle. You may still have some third-party APIs for very specific needs. Maybe it's an RPC call. But what we're trying to imagine is that you now have these pipelines being built. It's something linear. It's something event-driven. It's not something that you are just blindly trusting someone else to provide. It's this piece of software, this piece of engineering that you're able to iterate on as a product itself. But another way, control the flow, not the infra. So in an ideal state, you're controlling that flow of data, that pipeline itself, without having to worry about all the intricacies of managing that infrastructure underneath. So there are some next generation products, I like count Index & Co as one, others like Goldsky, QuickNote Streams. There are multiple coming out where they will push data to you, and that can be an entry point to your own pipelines. Importantly though, you want pipelines, not just streams. Streams is just the tip of the iceberg. You still have to actually do something with that data and have it embedded in that way, in that event-driven architecture throughout your system. All of this then kind of summarizes to faster pipelines equals less storage. If you have pipelines that can iterate on your data and you can adapt to different business needs, you can onboard new chains quickly. It also means you don't have to store all of that data up front. So you can get to the point where perhaps you're only storing your current user's data, and when a new user signs up, you can onboard that data really rapidly. So it saves you a ton of money in the long arc if you can focus on the pipeline itself. Last time I'll show this non-image, but the idea here being as you get more products, if you've already built the pipelines, those pipelines can then be reused for multiple different scenarios. You might be able to pipe to a different database. Maybe you're now doing business intelligence as well. The pipelines give you that flexibility to keep expanding. And yeah, figured I'd throw in a quick cheat sheet just from some learnings that I've had with data indexing in case they're useful. Use deterministic IDs, especially with on-chain data, not UUIDs. And this will save you massively in the future. You don't need joins in a table or joins in a database for on-chain data. Use things like block numbers, transaction hashes, log indexes, things that are deterministic. On-chain data is time series data. There's always a timestamp associated. A lot of times we forget about that and try to treat it static, but we can lean into this time series element to do things like continuous aggregations. There's some really powerful tooling around that as well. For anyone really deep into all this, there's discussions around Postgres versus ClickHouse versus whatever the new shiny thing is. Frankly, it's all negligible if you configure it correctly. There are very select use cases where it matters. 99% of the time it doesn't. So the call out here is to use whatever you're familiar with. If you're familiar with Postgres, use that. If you're familiar with ClickHouse, use that. Don't go chasing the shiny new thing. This is a little more anecdotal, but I've just seen this across the board, especially with on-chain data. 1 million records is about 1 gigabyte of data once you put it into a database, and you might have an index or two on it. So it's been a helpful frame of reference just for trying to scope sizing. And then, yeah, similar call out. Usually when we're developing on-chain products, we are QAing the end result. So we've integrated all this stuff. We've built those crazy graphs you guys didn't see. And you end up with a product where you're QAing the data from the UI. It's a really backwards approach. So the call out here is to build pipelines, unit test those pipelines. And so if there's something wrong with the pipeline itself, you can fix it there instead of realizing it all the way at the end user. So yeah, open data means data sovereignty. I think especially in this Web3 world, you should be able to control your own data. And then one small plug for the indexing company here. We support about 120 different networks. We do a distributed compute layer, meaning you get full control over the transformations on the pipelines themselves. And then it's all integrated into your systems. So we'll write to your databases. You control the pipeline as well as the data storage, and we just run the infra. Infra, not data. And then, yeah, we can onboard L1s faster than sharing a pint. I've done this twice now, so if anyone wants to buy me a beer, I'll onboard your L1 for free. Yeah, we're, as I like to say, indexing code is boring, so you don't have to be. Yeah.
Thank you, Brock. Any question?
I'd like to hear some more horror stories about your UUID recommendations against it. Also, have you used any type 1 UUIDs, which are timestamp based? Do you discourage those as well, or what are your recommendations there?
Yeah, I think the long and short of it is if it's coming from an on-chain source, it's already deterministic. So us adding another ID on top of it, at best, is just going to add extra data that we don't need. At worst, you're going to get drift. So if you, for instance, onboard an L1, you have a bunch of transactions, you realize you want to change your pipeline, you can't do a simple upsert anymore because your IDs are different. You'd have to drop your database, recreate it, re-index everything. If the unique and primary key is something from an on-chain source and deterministic, you can then get that ability to do updates directly.